What's up, everybody? We're about to get into absolute value and just a little bit of inequalities, just graphing and just going over some of the basic stuff. So stick around and don't be afraid to take a second sometimes if you need to pause and ponder. Let's get into it. Absolute value. So this is something that we've all seen before. So what we're going to focus on is just going over some of the rules and just kind of refreshing our memories with what this actually means. So for most of us, we know that when we see something like the absolute value of 13, we know that absolute values are always positive numbers. So the absolute value of negative 13 is just 13. And the absolute value of 55 would be 55. And the absolute value of 0 here is, of course, 0. What about if I was going to ask, what is the absolute value of negative 40 over 11 and that number, and there was a negative outside of that? Well, what we would do is we would work from the inside. So first I'm going to do the inside, and so we have, this is going to be 40 over 11, so 40 elevenths, and then this negative on the outside, it's going to stay there and just come along for the ride. And the reason that is because this would be like negative 1 times the absolute value of negative 40 over 11. And that's how we deal with those negatives on the outside. I always like to think of them as multiplication by negative 1. Another way to think of it is that the absolute value blocks the negative. So this absolute value sign here is actually blocking this negative from affecting whatever the value of the quantity inside of the absolute values are. So it's giving you that swift
Cry chop.
absolute value is also the distance from 0. So if we would have something like 12.8, and down here we'd have negative 12.8, notice that the distance from the origin, we can think of this as the x-axis, so the distance is 12.8 units, whether it's negative or positive. That distance is still 12.8 units from the origin, from 0. Let's see what we have here. It says the distance from 7 to negative 9 is, so from negative 9 and 7, so I want to know what's the distance between these two numbers. Distance is subtraction, so this is just going to be the absolute value of 7 minus negative 9. And remember that two negatives in a row make a positive. And so this is 7 plus 9. And that is equal to the absolute value of 16, which is just 16. And if we look up here, that means that the distance between these two numbers is 16 units. What about the distance from negative 10 to negative 39? Again, distance, we can find the distance by subtracting two things. So this is going to be negative 10 minus negative 39, two positives. So this is going to be the absolute value of 29. And that's what we're getting here. So down here we have a negative 39, and over here we have a negative 10, and the distance between these two numbers is 29 units, 29 spaces. Properties of absolute value. So we're looking at two absolute values here, and we want to know, is this true? Can I break up this expression? Is that legal? Is that true? Let's see. We have 7 minus 4 is 3, so the absolute value of 3 is 3. Is that equal to, let's see, absolute value of 7 minus absolute value of 4. Oh, that looks good. Okay, that was true. Yes, that was true. Let's see if it's always true. So we got negative 6 minus 3, so this is a negative 9 absolute value, and this is going to be 6 minus 3, negative 9, absolute value is 9, and hey, wait a second, that's not true. But up here was true, so is it always true? Can we always break it up like this? No. This is illegal. This is an illegal move. You cannot always for sure say that these two things are possible. For any number A and any number B, this is not always true. It's only true in special cases. So is this legal? No. Not legal. No. What about multiplication though? How's that work? Let's see what's going on. We got 2 times negative 10, which is negative 20. So that's the absolute value. Absolute value of 2 is 2. Absolute value of 10 is 10. So absolute value of 20, negative 20 is 20, 20, yes. This is a property that is always true. This will always be true. You can only break up absolute values over multiplication. So let's see something that looks a little bit more fancy. Up here we have a bunch of stuff going on. So first what we want to do is work inside of the absolute values and then make our way outside. So I'm just going to start at the top here. I see two negative signs in a row, two minus signs in a row. I'm going to make those positive, and I'm going to rewrite this as -2 plus 3 absolute value. And down here, I'm noticing, hey, wait a second, I have a -4 inside of an absolute value sign, so I know that that is going to be a +4 and a -6. So now again, working within the absolute value. I'm working within the absolute value signs. We have -2 plus 3. This is 1, and the absolute value of 1 is 1. And 6 minus 4 is 2, and so our answer here is 1/2. So let's take a look at this next example. What I want to do here is work within the absolute value first. So up top, I want to work with the 4 minus 7. So 4 minus 7 is going to be -3. Absolute value times that -2 over absolute value of -3 is just 3, minus the absolute value of 4 is just 4. So here we have the absolute value of 3. So this is -2 times 3 over 3 minus 4. -6, -1, so this is 6. So again, just remember to work within the absolute values. Think of going from the inside to the outside. It's kind of that idea of nested property that we see so often in math with things like parentheses. Think of absolute values in that same vein. We're working within them, then we go on outside of them, and we're moving along left to right, top to bottom. While we're doing the easiest stuff in the world, why not look at some of the easiest stuff in the world? Let's just knock this out of the way too. This is just graphing these inequalities. So because we did some graphing in the beginning of this, let's just look at some other graphing and see why it's the easiest thing in the actual world. So we have two numbers here, 1 and 5. Here's 1, and then down here is 5. And this is, x is all the numbers that are, let's read this half first. This says x is greater than, right? The alligator eats the bigger number. X is greater than 1. So what numbers are greater than 1? 2 is greater than 1. 3 is greater than 1, right? So we're looking at going this way. And let's read the second one. I'm going to do this one in blue. Just give this one a chunk over there. Let's do a little bit thicker in blue. A little thick boy blue. This says x is less than 5, because remember, we're eating the 5 there. Alligator's eating the 5, so x is less than 5. What number's less than 5? Well, 4 is less than 5. Hey, 3 is less than 5. So where do these two things overlap? They overlap in this region here. And so the graph for this inequality will be what we see in here. So I would just shade between these two regions. But we have to think to ourselves, is 5 included? Well, this is greater than. But is it greater than and equal to 5? No. And so we will have an open circle at 5. Is it greater than or equal to 1? No, it's strictly greater than. So this is strictly less than, and this is strictly greater than. So these numbers are not included. So I'm just going to make sure that these are not included. The idea is it's at 1, it's at 5, and all the numbers in betwixt. So let's look at what it looks like if it was to be a greater than sign. So again, I'm thinking x is, greater than, x is greater than -7. So I'm just going to go ahead and make a -7 here. X is greater than, what's that bottom thing on the bottom? Oh, that's the equals to. So x is greater than or equal to. That means that 7 is included in this set. So I'm going to put a closed circle. And x is greater than, well, what number is greater than -7? How about 7? That's greater than it, right? What about 2? That's greater. What about 0? What about all these numbers? Yes, and it's true that all these numbers are greater than -7. Let's see what we have here. We want to write the inequality from the graph that we see in front of us. So let's say that there's this shaded region in here. This is open circle, so will 4 be included? No. So this is going to be greater than or less than. So I'm going to write a -4 and some number. Let's think. Are there's what numbers in here? Let's see. We have -3, we have 1, we have 0. Are these numbers greater than -4? Yes. And so that means that x is greater than this, right? Because the numbers are greater than. And then let's move over to the 2. Let's see, we know that the 2 is filled in here, so it's going to be less than or equal to, greater than or equal to, right? Because it's a closed circle. And are the numbers greater than? Well, let's think. If it would be greater than, if x would be greater than, it would be numbers like 3, 4, 5, and these numbers are not included. So we know right away that's not going to be greater than. It's going to be, x is going to be less than or equal to the number 2. And again, it's pretty just very simple thing to ask yourself, what's going on here? Don't be afraid to be intuitive and actually engage with the material. You don't have to remember stuff. The only thing that I remember is which value means what. And it's if it looks like this, x is greater than the numbers. If it looks like that, the numbers are greater than x. And that's it. And for our final case, we have something that we see here. So let's just start off with what we know. Let's look at this side. Let's look at this side here in blue first. And so we have numbers like -8 are included, -9. Are these numbers greater than or less than -7? These numbers are more negative, and thus they are less than -7. And so that means that x is less than -7. And that means that the alligator, of course, will be eating the -7. Let's look at these values over here in pink. We have -1. So -1 is going to be our value in question. And we have numbers like 2, 3, 4. So are these numbers greater than or less than -1? These numbers are greater than. So x is greater than -1. And this is what we call a disjunction. This is what we call a disjunction. Nothing you need to know that. But these will be connected by the word or. It's one or the other. It goes this way or it goes that way. There's no in between. Thanks for watching, everyone. If you liked this video or you learned something, please make sure to hit the like button. And if you want to see more videos for your College Algebra 101 or just all your mathematical needs, don't forget to hit that subscribe button. As always, I'm out.